Hello everyone. I wanted to do a couple of quick videos to help with the last couple types of word problems that we didn't get to in class. So the first one is exponential growth or decay. So that's the one that we're going to be doing this time. So exponential growth or decay is basically an exponential function. It's going to look like, oops, let me see if I can. Here we go. It's going to look like P of t equals A times B to the t power. Again, this is your basic exponential function, a number times a base to a variable power. Basic exponential function. And what these things are, P of t, this is going to be your amount or your population at time t. Whatever value t is takes on, P of t is the amount or the population at that time. A, which is here, that number out front, this is your amount or population at time t equals 0. That means your starting amount or population. It's your initial starting point. And then your B value here, that's your base. Basically, it's going to tell you whether you have growth or decay. And it's going to decide how fast or slow you grow or decay. So basically, this B value, if that B value is greater than 1, then we have exponential growth. And basically what that means is your population or your amount is increasing as time goes on. As time increases, so does the population or the amount of stuff that you have. And that's what happens if your base is bigger than 1. Now, if your base is between 0 and 1, then in that case, if it's between, and just to be clear here, if your base is between 0 and 1, it's going to be a fraction. So if your base is a fraction or a decimal that's less than 1, then we are going to have exponential decay. And basically what that means is that your population or your amount is decreasing over time. As time goes on, you're having less and less and less things in your set, in your population. And remember, your b here is the base of an exponential function, so it has to be a positive number that's not 1. So it's going to be either a fraction, smaller than 1, or it's going to be bigger than 1. So these are really the only two cases that we have here. Okay, that's what b tells you. T is the other variable here, and this is going to be the time. Now, when we did the compound interest formula in class, your time had to be in years. But here, time does not have to be in years. It can be any units of time, just depending on however it's measured. So those are all of our variables, and that's what our function looks like. But one more thing to mention here is the growth rate R. This essentially tells you how fast, it's a percentage that tells you how your population or your amount is increasing or decreasing. So if B is greater than 1, then our population is growing or increasing. We're in exponential growth. Then to find your R value, you're going to take B and subtract 1 from it. And that's going to tell you how much bigger than 1 your B value is. And that will tell you how fast it's increasing. And similarly, if your B value is a fraction between 0 and 1, then your R value is going to be, again, the kind of how far your B value is away from 1, but we'll do 1 minus B this time since B is less than 1. So really what you're doing here is how far is b from 1? If b is bigger than 1, you'll subtract 1 from it. If b is less than 1, you'll subtract b from 1. And basically, in both of these, r is going to be a percent written as a decimal. And this is your growth rate, or sometimes it'll be called, let me see how Alex does it. Yeah, it'll just say, like, by what percent do you change? It's your percent change is really what this is. Yeah, percent change, percent change. That's really, let's go with that. So your growth rate, this is your percent change. There you go. That'll help you figure out when it's looking for your R. Okay, so let's do a couple of examples. That's what exponential growth or decay looks like. All right, first example. Suppose the future price, P of t, of a certain item is given by this exponential function. P of t is in dollars, and t is the number of years from today. All right, we are asked A for the initial price of the item. So P of t, this is our your price at time t. This 2,500, that's our A value up here. That is the your amount or your population. Here it's the price at time equals 0. Because that's our price at time equals 0, that's our initial price. So 2,500 is our initial price. So right here, we're going to have $2,500. That is our initial price of this item. Does this function represent growth or decay? Well, whether we're growth or decay is going to depend on the base of our function. So the base of our function is b here. Our b value is right here, 1.049. Is 1.049 bigger than 1, or is it a fraction or a decimal between 0 and 1? Well, that's bigger than 1, so that means we have growth. Right? If b is greater than 1, we have exponential growth. And then the last one, by what percent does the price change each year? Because it's a percent change, this is looking for our growth rate R. So again, we're going to find the difference between B and 1. Since our B value is bigger than 1, we're going to take that B value and subtract 1 from it. So we'll do 1.049 minus 1, and we get 0.049. This is a percent written as a decimal. And so what that means is that the price changes by 4.9% each year. That is how fast this exponential growth is growing, by 4.9% each year. All right. Number 2. A study is done on the number of bacteria cells in a petri dish. The population size, P of t, after t hours is given by this exponential function. Okay, so P of t, this is the population of bacteria at time t. 2,000 is our A value. That's the population when t was 0. So that means that's our initial population. So we had 2,000 bacteria in our population at the start of this whole thing. That's our initial population. Does this function represent growth or decay? Well, to figure out whether this is growth or decay, we're going to look at our B value here. Our B value is 0.85. Is that bigger than 1, or is that a fraction or a decimal between 0 and 1? That's between 0 and 1. It's less, oops, that's not what I meant to say. It's less than 1, right? It's a fraction between 0 and 1. Because it's less than 1, this is decay. This is a fraction. So the number of bacteria cells in this petri dish is actually decreasing. We're losing bacteria. And so we want to know, by what percent does the population change each hour? Because this is a percent change, I'm looking for R. And again, that growth rate R is basically how far our B value is away from 1. Since our B value is less than 1, I'm going to take 1 minus B to find R. So to find R, I'm going to do 1 minus 0.85, and I'm going to get 0.15 when I subtract that. This is a percent written as a decimal. So 0.15, that is 15%. So the population changes by 15% each hour. And again, this is decay. So the population is decreasing by 15% each hour. That's how this exponential function is changing. All right, so that is what exponential growth and decay looks like. Good news is that we are going to give you the equation for these. You just kind of have to know what each thing represents. Again, A here is your initial amount. B is your, it's basically the base of your exponential. That tells you whether you have growth or decay, by whether it's bigger or smaller than 1. And T is your time. And your growth rate is just the distance between 1 and your base. And that's a percent written as a decimal. All right, I hope that helps with this one. And I'm going to do one more for continuous exponential growth and decay. So I will see you in the next one.